Hi, welcome to FunNetPy videos. This is DC here. In this video, I'm going to show you how to use NTAG213TT Nfc tags. So this is a product for NXP Semiconductors. So NTAG213TT, TT stands for tag tamper feature. What basically it means is, so this is one of an example block diagram of this NFC tag. Now if you look at the diagram, so you have got the antenna here that is to pick up the power from the RF reader writer. It is this bit here, this bit. So what the tag does is, so whenever the tag basically monitors this connectivity, if there is a break in the connectivity, the break may be because somebody has pulled this tag. You know, these tags are very popular in packaging industries. If somebody has pulled this tag, and if this connecting wire, if there is a break or a cut in the connecting wire, the tag remembers the status of this connecting wire. So it knows if the connecting wire is open, that's if it is broken, or if it's closed when it is not broken. So this is one of the most important feature of this tag. Otherwise, this tag is very much similar to NTAG213. It has a very identical memory structure with the locks like the dynamic locks and static locks, with the mirroring. Now mirroring, is one of the most interesting feature of this NTAG213 tag is mirroring, where something about the tag like a counter or the UID or some data can be made as part of the NDEF messages without any programming, and something like it also has got a counter as well. So this tag, besides what's in the NTAG213, you can also set the tag tamper data, or it's called tag tamper message. So you can send a message whenever this wire is broken. And don't think you can put a message with hundreds of bytes. You can have a maximum of 4 bytes of tag tamper message, which is automatically made to mirror and send in the NDEF messages as soon as the wire is broken. This also has got a feature called changeable originality signature, which is present in the NTAG210mu. So basically, NTAG213TT has got the features from NTAG213 as well as a feature from NTAG210u. So because of this reason, in this video I'm not going to cover anything about NTAG213 or anything about the changeability of signature, which I have already covered in 2 separate videos, that NTAG210u. This is a very recent video I have made on showing how to change the signature. So like we did with all my previous videos, we are going to see the NTAG213TT datasheet. We are going to compare this with the NTAG213. We'll see what's difference and also see some of the new commands that are related to the tag tamper, and also the new commands that are related to the change the original signature. So we're going to see how to read and write and do all this, detect all this tag tampering using 4 reader writers. So in this video I'm going to show you how to do that in ACR122u Reader writer. So this similar feature will be made available in PN532 software, Omni Key Reader software, or CR95HF based software. So probably these videos, when I do, will be a kind of a repetition of this video. So with this background, I'm going to show you how to use this tag, and you can buy these NTAG213TT tags from internet. However, I did not see any website where you can buy in a pack of 10 or 50. You have to buy in thousands or 10,000 tags. So I would like to thank the Syndicate Group company who have given me a few sample NTAG213TT as well as NTAG413 the DNA. So that will be my next video. So if you look at this website, this company manufactures tags. So probably they buy the microchip from NXP and they put the backing cover or the antenna, and they make tags for various applications. So probably if you want to know more about how these tags are used, I advise you to go through this website. So thanks for that. So I have made a video on NTAG213. This video was made pretty long ago. So if you search understanding NTAG213, you will come across this video. If you want to know more about NTAG213, I would advise you to go through this video. And in fact, this video is also using ACR122u. And this video is a very recent one called Introduction to NTAG210u. In this video, I have explained how to use or how to modify the originality signature. It's exactly the same feature which is also available in this NTAG213TT as well. So this is what the tag looks like. The first two tags, this have already tested it, and this is the one I'm going to use in this video. If you look at this tag here, this is the standard tag with the tamper wire intact, which is connected here. And these two tags, as you can see, I have just chopped off the tampering wire. Now this is what the tag can detect. So I'm going to show you these two tags. If you try to read this broken tags, the tag tells you that this wire is open. If you try to read this, the tag itself tells that this is a closed wire. Okay, so this is a very interesting thing. You can think about the applications where these tags will be used. For example, to identify the products, for packaging, there's so many things. This is the data sheet of NTAG213TT. You can get this from the manufacturer website. So this is the memory structure of NTAG213. You can see it has got 45 pages. The last page has got the pack value, and the last page number is 44. And this is the NTAG213TT. Everything from page 0 to 44 is the same, except there are a few changes in the configuration which I'm going to show soon. This one also has got the page number 45. This is where the TT message is stored, and as I mentioned before, the message can be only 4 bytes. Now that's the only difference between NTAG213 and NTAG213TT. So there is a very small change in the configuration pages, and this is the configuration page, page 0 and page 1 of NTAG213. It has got mirror byte, mirror page, auth 0, access, and that's all the first two pages. If you compare this with NTAG213TT, you got the mirror page and auth 0. This is very similar to the config 0, except this is RFUI, whereas here this is reserved for the tag tampering TT. If you look at the configuration page 42, access, this is exactly the same. There is a small change in the number of bits used for configuration. So here it has got only 2 bits, whereas here there are 3 bits, because there are 8 combinations of data that can be mirrored. So you got the UID, and if you think about this NTAG213, the data that can be mirrored are just UID and the counter. So you got only 2 combinations here, sorry, 2 types of data, and you got 4 combinations. Whereas here, so you got the UID, the counter, and the TT message. So you got 3 entities here, so you got 8 combinations. So that's why you got 3 bits to tell what kind of data you want to mirror, and everything is the same. If you look at the TT byte, which is the byte 1 of page 41, so there are only two things here. The TT enable, if TT is not enabled or tag temp is not enabled, this tag behaves exactly like the NTAG213. But when this is enabled, this tag will detect if the tamper tag is open or if it's closed as soon as the tag is powered. The TT lock, it means you can lock the message that is written here. Once the message is this is kind of a locking a page, so you know that any page in NTAG213 can be locked by either a static locking or a dynamic locking. So this is very similar to that. When this bit is 1, it locks the page number 45. So from that point on, it cannot change the content of this TT message. So regarding the additional commands, this is one of the new command called read TT status. This command will return whether the tamper wire is open, closed, or if it is not enabled. So if you look at that, so this returns a 5 byte response. So the command is A4 and A0. These are the commands you have to pass, and the output is if the TT, the tag temp enabled, you will get the 4 bytes as a TT message, and the last byte will tell you whether it's a tag is closed and open or it is not enabled at all. So that is with the value 434 up and 49. In addition to this, there is also a command for changing the originality signature, which is identical to the NTAG210u. So with this background, I'm going to show you now, just try to operate on one of the NTAG213TT tag. You can see here I've connected my ACR122u Reader writer, and the software is ACR122 Made Easy version 1.7. So you're going to choose the NTAG213, the third option. Probably it's better to have /TT as well. Now I'm going to place the tag. It doesn't matter how you keep. So sometimes you have to struggle to get this tag recognized. Either you move there or down, or if you hear a beep from ACR122, it means that your tag has been recognized. So activate. Now you can see here the software has detected its NTAG213TT. So how did the software do that? It's all done using the get version command. In the get version command, everything is same as NTAG213 except the major product code, which is 03 for TT and 01 for NTAG213. So if you are using this in a software, you have to probably you can compare this 8 bytes and recognize which is TT or a normal NTAG213. It has got the signature, and because this is a TT tag, we have added a separate tab here that's called TT tab. So which where you can do the signature modification and locking the signature, which I have explained in NTAG210u. But this is the command called getting the TT status. So I'm going to read the entire tag. The tag comes with the default empty NDEF message. So I don't think you can buy this tag without any NDEF initial NDEF message. So the only drawback with these type of pre-written data is you will lose the OTP functionality. So now if you want to use it for ticketing, probably you would expect to have an empty OTP, which you may not get it. If you scroll down, everything up to here is the same. You only have an additional TT message, which we are going to do that. I'm not going to explain anything about locks or dynamic locks. It's all done in my early videos. So I'm going to, first thing we do is put a message for you want when the tag is tampered. I'm going to say the message will be A1, B1, C1 and D1. If you want to know all the commands that are going, it's a simple write command. So write to page 45 successful. So this is fine. In the configuration, again, there's a small change has gone into this software. It's the same screen you'll be seeing for NTAG213 as well as NTAG213TT. Just to accommodate this TT lock and TT enable, all these previous controls have been rearranged. I'm sure you will understand what these are. So the first thing, the steps you carry out when you use these NTAG213TT tags are: you first set this message, then you're going to enable it, or sorry, you're going to lock it so that nobody can modify this in further, then enable the tag tampering feature. Without this enabled, the tag will never detect whether the wire is opened or closed. And you should also keep in mind, the tag detects only when the tag is first activated, not later. If you just hold this and start tearing the tag here, the software the tag will not recognize that. So, and also you have to be very careful when you experiment. I happen to break cut somewhere here. In fact, that made my tag non recognizable. Probably this is some of the wiring, I think it's part of the antenna. It all depends on how this this tag is manufactured. Maybe it depends on it also depends on the manufacturer also. So okay, we got the TT message. If I go to this TT tab and read, now this is the new command. It's called the read TT status. So this has returned me 5 bytes with the first 4 bytes as zeros, followed by X49. If you look at the documentation, the X49 means it's incorrect. So we know that I have not enabled the TT functionality, so that's why it says this is incorrect. So this status is not right. So that's all about. Now one more thing I would like to bring to notice here. This tag which I got from the syndicate group, so by default the signature is not locked. So this is pretty open. I can go and modify the signature. If you see my NTAG210u tag, you will come to know that NTAG210u comes with a lock tag. You have to first set the unlock command, then you have to write it. So again, this depends probably on the manufacturer, what kind of chip they receive from XP. So I'm going to write. So the write is successful. If you go back to the signature and read, so okay, so if you see that somewhere here the new values are included, we just modified your signature. Now I'm going to first assume that this is the lock we want. I'm going to, before you do that, you can configure where you want to mirror this. I'm going to use, if you look at here, there are more options in the mirror drop down list. The first 4 is what you will see in NTAG213. The remaining 4, what it means is, it means I can mirror just the TT, that the tamper message, or I can mirror UID and the TT, or UID and the counter, or the UID. I'm not sure it's UID in the counter. There's something wrong here. 6, or it is probably say TT and a counter, not UID and counter. So it is or UID counter and TT. I'm going to choose all. So assume that I want to mirror all this data starting from say page number 10. So again, this mirroring is a very interesting concept. If you are working with NDEF messages, you know that all these value UID counter TT can be overlapped on your NDEF message. And to be careful, you have to have certain number of bytes before you set this. So I want my mirroring of this 3 data to happen from page number 10. So I'm going to use page number 10. I'm doing so many things in this configuration now. I'm also going to lock it so that nobody can modify. I'm also going to enable it. Okay, so what we did here is we first set the mirror configuration, which is the feature available in NTAG213, and we also said I want to log this message that is in the page 45. I don't want anybody to modify that. Plus we also want the tag to start detecting whether the wire is open or closed. So right, so the configuration 0 is been written. Now this is enabled. So I'm going to take this out and try again. Choose NTAG213, activate, read. If you go to TT and if you say read, we got a different message altogether. It says all the first 4 bytes are zeros, and the 43 means the document is closed, so the wire is still closed. And also once after we enable the TT here, you can never read the message here. It's completely hidden. The only way to know this message is you to look for, if you look at here, say if I go to the character mode, so because we are enabled the mirroring at page number 10, and also the mirroring is set to UID, counter and TT, you can see that the entire UID here it's been mirrored. And the counter, we don't have the counter, and we don't have the TT message because I have not enabled the counter. Again, this is a concept of NTAG213. I'm just going to show you quickly enabling the counter, right? And every time I activate, read, if you read the counter, every time you read, the counter value keep on increasing. This again a very interesting feature if you want to use this as a smart poster. So because the value of the counter is mirrored, you'll come to know how many times somebody has typed the poster. That's an interesting feature as well. If you look at here, in this, because there's a counter value, the mirroring so far, what you can see here is the UID followed by the counter 1, which is is using 6 bytes here, 00001. Okay, so the last thing which you have got to do now is to break this. So if you're demonstrating this, I'm sure you'll end up destroying a tag. Now what I'm going to do is take this thing out, and I'm going to chop this. Probably now you don't have to chop. Probably if you just put a crack there should work. Okay, read the message. If you go to the TT here, look at that. Now because the wire is open, what you see here is the 5 bytes, where the first 4 bytes is the message, and this message here which you can't see, followed by the 4F the documentation says it means it's open. And if you look at this, the mirror place, go to the character, and you can see that you get all the 3 things here. You got the UID separated, there's a small X character that separates out all the 3 components of this data. followed by the counter X, followed by the tag tamper message A1, B1, C1 and D1. So I think that's all you got in this tag. It's a pretty straightforward. If you know NTAG213 and NTAG210u, so this tag is fairly easy. I would advise you to read this documentation. It's very interesting and it's also easy as well. Okay, that's all. Thanks for watching.